Today is part 2 on the water heater gas-fired conversion to wood burning. So this is where we're going to be putting the wood inside here, and we're going to show you how we've leveled this one out because we're going to have a secondary one. So basically, if you just take a level on the sand and figure out where it is level, and then it gives you a lot easier way to level your cinder block into the sand, and then we could put our cinder block down and give it a nice base to have the water heater sit on. I'm going to be using some copper tubing today, and we're not going to do the traditional type solder. We're going to use what they call a copper ProPress tool. But we also have a Milwaukee cutter here too, so we can just stick it right on in the right placement. And there is a sight hole right there if you need to see where you're going. And then we just flick the button, cut it. Gavin, you want to grab the other side? And there she goes. So then the next thing we want to do is have a nice clean end. So we take a brush and we just kind of go across and do one more time. That gives us a nice clean end on that side. And we do it like this. This one's a little dirtier. Maybe we'll try going backwards. That makes a big difference. And we'll do that on the same side here. Alright. And then we need to clean this end. Would you like to clean that, Mr. Gavin? So then the next thing that we're going to do is we're going to press this on what they call copper ProPress fitting. So it has a O-ring inside, and then the tool clips right around this. So this would be your copper ProPress tool, and basically you can just slide it in like this, and then lock it down and fit it properly on the pipe. So we're going to do the first fitting on the water heater, but since we don't know the correct angle, we're going to actually do the pipe first, and then we can adjust this to where it needs to be so that way it fits better. And we need the other side. Push it in and out when you're moving it. There you go. Alright, so we're going to put the pipe in here. And you want to make sure it's in there good, so you'll feel a good stop. And then we slide the tool down over top, open the jaws, let the jaws go, and hit the button. And that beats soldering any day of the week. That's 5,400 pounds of pressure squeezing around that fitting to make a good joint. So then next, we're going to do the water heater fitting, since this is where we would like it to be. Move it a little bit more to the side. And cut. We use copper for certain things, and the main reason why we're using copper for this particular reason, it's going to be right up next to the exhaust, and we want to make sure we don't have any plastic fittings over there because they can overheat and break or melt, and we don't want that. So this is a PEX fitting that we're going to be transitioning from copper to PEX. Then we do the last one. And that's how a copper ProPress tool works. 1/2 inch, 3/4, up to 1.25 inches with this particular tool, just by changing the jaws out and cut. So we're going to be doing some PEX pipe. This is a PEX cutter, and basically you go down and start squeezing and twist the tool, and then that'll allow you to cut it much smoother. So then we use what they call a stainless steel crimp ring, and we slide this over top of the pipe, and then they have this little dimple here, and that goes inside the PEX crimper gun, just like so, and then you squeeze the trigger and put it on. So we'll make our first connection and put it in like this. And then it'll tell you if it's good or not. It has a green light. And then we'll put the next one on. And you make sure you put a little bit of a gap in between so there's a little bit of pipe showing on the end. That way you don't go too far. And that's how you crimp PEX. Ready?
I'm recording.
So this part of the pipe is we're going to stick straight up and down out of the water heater. And the purpose of having this pipe is it's going to be a gravity flow type system. So the purpose of a gravity flow is that there's no pressure on the system, because water under pressure is harder to heat. And so if there's no pressure, it's easier to heat the water. If you put water in a vacuum, you could boil water at 100, 115 degrees. If you have water under pressure, it takes up to 230 degrees to boil water, depending on how much you pressurize it. So part of this is to make it gravity flow, and the reason why we're putting a valve on it is so you can actually see how much water is in the system. Okay, so we got everything all situated here, and we're getting ready to start the fire. The water temperature is currently 69.4 degrees, and these guys here are getting ready to lay the tile floor down. And we just got ready to have the rest of our preparations for a firebox made. There's a heat shield that's in the bottom of this thing, so we just cut that in 2 places and it pulled out. And I just used the gas tube. That makes a nice handle. Put a hinge on there, and I cut a little bit more of the bottom out right here, just because that way you can scoop the dirt out. You can see where it used to be, I mean the ashes. So there's one piece in there I can't quite get. I'm interested to see this here, that screen, that is the air intake. So that really might make her fire right up. We'll see what happens. And so we got it all air purged, and now we're ready to fire it up. Okay, so we just used a bunch of little scrap kindling wood here, and we're getting ready to just set this off. It is 2:15 in the afternoon, and we're going to kind of time it to see how long it takes to come up to temperature. 180 degrees is kind of what I'm looking for. That'll tell me that it's going to get really good and hot. And we really don't want it hotter than that, but obviously that's not too bad. Just have to control the fire some. So one of the issues that we're concerned about is how much condensation is going to come out of this chimney pipe. You got all that cold water on the inside, and it could literally just start like raining inside here with condensation. So that's one of the first things that we're going to have to find out and use as a test. And then the second test we'll do in a day or two when the water's still hot in here. We want to see if we have the same type of results. So as you can see, we are getting condensation, and that's what we was wondering about. So it's trying to put my fire out while I'm trying to make the fire all at the same time, because of the way all that cold water in there. So once we get the cold water out, this will stay lit very easy. I'm thinking it probably has to be like 100 degrees just to stop doing that. Well, technically all it has to do is get above the temperature it is outside, and the temperature outside is 81 degrees. So once it gets 81 degrees, things should change. So it's been 15 minutes. Whether or not you can hear it or not, it's bubbling in under there. It's still raining pretty good. The condensation is off this part of the pipe. So I'm saying that our water temperature is getting warmer. So we're gonna go get a temperature probe here and see. So we have 103 degrees, 107 degrees. Now I don't think this is flowing yet. Our stack temperature is only 161. Now normal fireplaces run between 400, 500 degrees, so it keeps the creosote out. And it's not smoking too much, but our fire is not very big either. It's just this little guy here. Still raining, but the water on the bottom is still probably cold. Actually, it says that this is 110 too. I think it's broken because there's no way that's 94 degrees. I have my other temperature probe at the house. I forgot it. I apologize. So this is 19 minutes into it, and the stack is now too hot to touch. It's been 45 minutes now. We are at 89 degrees, and I have the circulator on so we could measure the return temperature. So it actually is probably warmer than that coming out of the top, but that's what we have inside. And so now we're above the ambient air temperature, and it does not appear to be raining in here anymore. So my prediction is correct. As long as the water is as warm as the air, it won't rain inside, so it'll make it so much easier to keep a fire going.